When we look up on a clear night, we can see countless points of light scattered across the sky. Each one of these points of light is a star, just like our sun. A star is formed within a huge cloud of gases and dust particles called a nebula. Inside a nebula, gravitational forces pull gases and dust particles towards each other to form a globe. This compact globe of gas is called a protostar, and its formation marks the birth of a star. Inside the protostar, gravitational forces continue to pull in more gas and dust particles while compressing the core so that it becomes hotter and hotter. When the temperature inside the core is high enough, nuclear reaction occurs. The nuclear reaction inside the core converts hydrogen to helium while releasing a huge amount of heat and light during the process. At this point, the protostar begins to shine and a new star is formed. A star approaches the end of its life cycle when it exhausts its supply of hydrogen fuel in the core and starts burning the hydrogen in its outer layers. This causes the star to expand rapidly and becomes a red giant. When a medium-sized star with a mass similar to the Sun becomes a red giant, it will expand until the outer layers are eventually ejected. The hot and dense core left behind is called a white dwarf. When a star that is much more massive than the Sun reaches the end of its life cycle, it expands to become a supergiant. Due to the large mass of a supergiant, gravity eventually causes its core to collapse rapidly, resulting in a big explosion called a supernova. As a result of the supernova, the outer layers of the supergiant is expelled into space, leaving behind a very dense core called a neutron star. For a very large star, it will also expand to become a supergiant and then undergo supernova at the end of its life cycle. However, due to its extremely large mass, the core collapses further and becomes a black hole. The gravitational force of attraction of a black hole is so strong that even light cannot escape from it.